Okay, let's get started. Remember, for those who were here for last workshop, we were not able to finish what we were about to cover completely in last workshop. So we'll start with just some quick review of lists and some implementations of a command such as append. So, for example, with what we learned in workshop one, we want to do a quick program on which days could we potentially have a picnic. And we have, let's say, a weather report for next 7 days. Give me a second. I'll just go copy paste this. I have to type down the whole thing. Give me 1 second. So here is a list of the next 7 days weather report. And with what we've learned in class for workshop two, I'll give you guys 5 minutes to quickly run a for loop, not a for loop, but a if else and for loop conditions to print out if we can picnic or not. For example, if it's raining, then we cannot go to picnic, and then we want the program to print out no. And if it's sunny or cloudy or anything else, then we can go to picnic. Then we want the program to return yes. And this is just a quick practice question review of our last workshop. I will give you guys 5 minutes to try to type down the program yourself, and we'll go over the questions together. Those workshop files, if you were here for the last two workshops, if you sign up, I believe I shared a folder with you guys with all the notes and stuff in it. But right now, oh, okay. I will share the workshop notes for last workshop in the chat right now. And after this meeting, I will send a general email with all the links, notes, recordings, and everything that. So if you don't have access to the whole thing, don't worry about it right now. And that's a Colab notebook to the previous workshop that you can use as a reference to complete our in-class task. And I'll wait till 3:08 to see if anyone could make this program working. I guess I'll just start right now because since some of you are not here for last workshop, and it might be too fast to just get you guys programming. So let's create a variable called picnic, and we want it to be a list, right? And now let's set it as an empty list because we want to pen yes or no if we can go to picnic in it. And for I in forecast 7 days. So we want the system to run through every item in the list if we wanted to determine if it'll be a raining day, and if I is rain, picnic. We want to print out, no, we cannot go to picnic. Else. And for all other conditions, doesn't matter if it's sunny or cloudy, we can all go picnic. Then we do picnic, append, yes. And now we want to print picnic. See? And now we got a new list with determination of if we can go to picnic on this day or not. It's very straightforward with what we've learned from our last workshop. And then let's do another quick practice. For example, we want to figure out how many layers do I want to wear for the next few days. So again, as I said many times, I highly recommend you to have your Python shell open or any sort of IDE open and just do type together with me. And now we have forecast temperatures. I see a question, but I would not go through and solve it right now because I want everyone else to be able to follow with me. If you have questions, do stay for a little bit longer after the workshop and I'll help you with it. So we have a forecast temperature. Sorry, I missed a comma here. Layers. And now it's the same thing we create a new empty list and we call it layers. And then we want to run through every item inside the previous forecast temperature list and decide what we can wear. So let's say if the temperature will be lower than 60 degrees and we append wear a jacket. Oh, sorry. I missed entire thing for I in forecasted temp. If if I is larger or equals to 70, we want to append don't need a jacket. And the last scenario, anything that's between 60 and 70, then we want to wear a sweater. And oops, my bad. Let's run through this program. Oh, I missed print, sorry. Print layers. Okay, now we get another list. It's basically same as what we had as our picnic practice. The one difference is we add one more condition, elif in there. So the system goes through if and then determine elif and then the last condition. So we just added one more condition. In our last workshop, we didn't get to cover a while loop. I will quickly show you guys a practice question with a while loop. And if you're still unclear about it, it works very similar like a for loop, but it's basically a combination of for and if. I'll show you guys the example, and if you have any more questions, you can go over the note that I just shared in the chat. And then any more questions, feel free to ask me in the office hours. And then we want to use the while loop to determine the usage of a gift card. So we have a starting balance, let's say 100. And this is initial balance. And while balance. And here we assume that we use about $20 each time, just to make it simple and straightforward. So we want the reason that for here, this one, while balance minus 20 larger or equals to 0, which means before we do our last purchase, if it's 20 each time, we want to be able to, we want the program to show us how much balance do we have left for that we can still make a purchase. And once we made our purchase, we want the program to print out how much money we have left as our final balance. And let's run through this program. And now we can see that the system will run through every purchase for $20 and then with a final balance of $0. we have 0 left. And if our initial balance is 110, you'll see the final balance would be 10 instead. I'll just quickly run it. Yep. So that's a quick usage of while loop that we didn't get to cover. And now let's start with what we scheduled for today. Today we will be going over pandas libraries and matplotlib. So pandas is library is a popular data science library which allows fast access to to all sort of like, especially in CSV files and data sets and analysis for structured data. It's often used for Tableau data data which gets converted into a 2D data structure, which means rows and columns, which is called a data frame. And for on this section, we'll be working with a data set. I will send the data set link to the chat because I uploaded it to the GitHub. Just give me a second. So we will also show different ways of import files in pandas. But let me share this file with you guys with the GitHub link. 1 second. So I've posted on the data file in the chat. It's called Outbreaks. It has certain distributions such as year, month, state, location, food, ingredient, spices, status, illness, hospitalization. It's basically and facilities. And I've shared the link in the chat. I will give you guys a minute or two to quickly look through the data set and understand what we're working with. And then I'll start using pandas to manipulate this data set. And let me know if you have any problem opening that file from GitHub. Yeah, you don't have to import it to pandas yet or Python yet. I'll show you guys later. I just want you guys to look and take a look at and have a gesture of this data set looks like and what is this about. And I'll wait 1 more minute to have you guys take a look at this data set. Sorry, I just got some background noise. If you don't know the difference between one equation mark and two equation mark, that means you're missing the previous two workshops. One equation mark is assign a number or a list or any sort of data types into a variable, and two equals mark is equals. So in programming language, one equation mark is not equals. It means assign a variable. Yeah, if you don't know that, feel free to watch the recordings for the previous two workshops. And let's start with how to import CSV files into pandas. So first we import pandas into PD. I'll just erase all those. Import pandas as PD. And for sometimes for documents at GitHub, they have like a security layer, and there's a code I'll also paste here that kind of lets you just get rid of the security layers of GitHub or other sort of database. It's called SSL. It's called Security Socket Layer, and I will share. I'll just type it down. It's import SSL. This step is not always needed. It only needed if you get an error saying that you don't have like the authority to access the data or something like that. If I have a typo, please excuse me because I'm so bad at spelling and then there's no autocorrection. Create. Create unverified. I will copy paste this 2 lines of code in the chat so you guys can just paste it in your program. That's how that allows you to get you through the login process of GitHub. And then, so there are multiple ways of importing files into our Python program. One is import directly from your directory. So assume that your data file is saved in the same folder as your Python file. Keep in mind, same folder. They have to be in the same directory. And then what you can do is df assign pd.read CSV. And then all you need to do is you type in your file name over here. Today, we will not go over any other data types, but just CSV files, because that's the one that you probably most commonly used. And data file, this one, again, is a variable. It can be any name. If you want to call it outbreaks, that's fine. It can be any name. And then you assign a data file to this variable. We'll use PD data file here, df. So this one, I'm not gonna run it because it's definitely gonna give me an error because I don't have any file saved in the same directory. Oh, I do have not breaks one. Oh, let me try it if it works. I even forgot that I have it saved. Control R. Oh yeah, great. So so that's how you import from the same directory. And again, you can see over here that the outbreaks CSV, it's saved under the PY file under the same folder. And now assume that we have a CSV file that's inside a different directory or different folder. Excel is kind of, So CSV is a different form of Excel. It's kind of like that. The only difference is CSV. Well, there are a lot of difference, but if you want to do data processing, I highly recommend you to convert your Excel to a CSV file before you read into it. Yeah, so it's once you open the file, it looks just like the Excel. Only difference is CSV, you can only have one table, you can't have multiple tables. Right. And now, so assume that we have different directories. And what we need to from different directory. I'm not sure if I have any other files downloaded, but what you need to do is you need to manually type down the directory name. So I want to go to users. I think my name is not Apple. Yeah, you want to go to users and then your account name, and let me see if my download folder has any file. Oh yeah, my download folder happens to have a file. I will use that as example. Download, and that one is called export, I think. Not sure if this one will work. Let's print df. Okay, yeah, so here I have a file called export.csv under my download folder. That's like a demographic data of New Jersey. So as we can see that the file is imported from from a different directory, and it's annoying in the way that you kind of sort of have to type down every single layer of the directory if you want to import it from a different folder. But if the two directories share the same file name, for example, we all started from users, and then they all under this is my name, my account, and then the difference is one is under workshop, one is on the download, and then for the shared directory, you can just use // to just sort of avoid the typing. But I will focus on how to read from URL because that's more stable and you don't have to worry if you move the data or you make some edits or lost a data file. That's I would recommend you to guys always, if either create a Google Drive folder or have a GitHub and just upload all your data sets onto there and then import it from your GitHub. And that's what I do. And let's go back to that link with the file. Let me copy the link. And it's very easy. You just set URL is what, and then data file is pd dot read CSV, and then URL. Or you can, another thing you can do is that you can just put your the link inside without having assigned a URL to what. You can just do like paste the link directly inside this parentheses, but we'll still assign it as a URL to make it easier for you guys to view. And then we printed a file. All right, and now we see that it's successfully imported and it's from my GitHub. And now let's go through some basic data manipulation for this file. Oh, another thing I want to mention to you guys is I will quickly change my share content session to GitHub. So for example, if once you upload a data file to GitHub, right, this one is too large, it cannot show. I will, let's see if I have other CSV files. So first, once you click on your file, it would look like this. So if you copy your link from here, it would most likely will not work. And what you need to do is you need to click raw and then copy the link from here and then import it to Python, not the link, not the first level of links. This will just take you to this GitHub page, not the data file itself. Okay, let's go back to Python. Now, first we want to show first 10 rows of files. We don't want to see the entire data file anymore. Oh, I forgot to print. So here, if we want to print first 10 rows of files, we can just use a function called data. Sorry, I got a call. Let me hang up on that. Oh my god, I have so many Apple devices and are running on at the same time. It's kind of annoying. Sorry about that. So yeah, if we want to see the first 10 rows of files, we can just do data file.head. And please notice that as we see, it only goes to number 9 of rows was because the first row, the first row of names, it doesn't take space. But again, like we said, the index always starts from 0. So of 10 rows, the index number of the rows would be number 9. And if we don't put anything inside this function and we just run it, the default would be 5 rows. Yeah. And then we want to show last 20 rows. Data file, tell. So when you use Python shell or an IDE, you always need to print, put the command inside a print. But if you're using a Colab notebook, I'm not sure about Jupyter Notebook, but you don't have to type print every time. And now here it will show us the last 20 rows of the data set. The default is also 5, I believe. Not sure. Yeah, it's 5. And next, we can also get information along with information about the data types using a function called .info parentheses. So print data file .info. We'll see some basic info of this data file. like how many columns, what are the numbers of variables, stuff like that, and how much memory it takes. And we can also get a summary of statistics of the columns with numerical data using the .describe method. And here, this will give you a summary of statistics. For example, how many years we have, how many rows of illness we have and hospitalizations, what's the mean of it, and what are standard deviation minimum, 25, 50, 75%, and the maximum number of those different attributes. And what about, we want to see all the column names in this table. We can do define dot columns. So here we'll show you the first all the attributes or the variables on the very first row, which has the names of different columns. Yes, the name of different columns or with different variables in it. And we want to know how many columns and rows are in this table. We can do df.shape. And that will show you. So here it starts with rows and then ends with columns. So we have 19K of rows and 12 columns in this file. So it's quite a large file. And there is a unique. There is one command that might be useful. It's called .unique function that will return unique values of a series object, and uniques are returned in order of appearance, and hash table based unique therefore does not sort. So that so for example, if we want to do data file, we just want to see the column called PM, and then we do a unique. Oh, wait 1 second. It's probably there's no, the variable name was changed. Let's see. Give me 1 second. Let me go back to the data file and see what are the variable names. Let's have year, month, date, location, food. Oh, okay. Yeah, sorry. There is no, as variable names were changed, there is no variable called PM. Let's randomly choose one. Not sure if it works, but let's use ingredient. So you will show you the variable that's not repeated, but I'm not sure if this ingredient has any non-repetitive. data file. Okay, yeah, this works, but it's kind of messy. So it would return everything that's not repetitive, basically. And apparently we have a lot of non-repetitive variables in this data set. And we can do, let's try if we can import another data set that's maybe more straightforward. Give me 1 second. Let me go back to my GitHub and see if there's a more straightforward data set. This should be the one I was talking about. Okay, yeah, so this is better. This shows a unique value that's in the data set. It's not repetitive, and this is numerical data. So it's probably better. I will share this in the chat again. This is the environmental science data. So this one has more numerical values. So once we want, for example, we can do more things about it. If we want to get data, then when the variable VOC is larger than 206, I will, let's print out what we have in this data set and see what variables do we have. Okay, so we have variables like times, local time, PM, temperature, humidity, carbon dioxide. I don't even know what this refers to, and then global. And then let's get the data if the VOC is larger than 206. And all those data, one is the first be the times. All those are numerical data, which is great, except for the time. It's a time data. So let's print. If we want to locate certain rows, not rows, if we want to locate certain columns with certain names, we can just do the data file name and then bracket and then the name of the column. And we want to set 206 as a bar. And here this program will now show us every rows that with the VOC that's same as 206. And if we wanted to larger or equals or just larger, we can just do a larger. And now it will return all the rows with the VOC that's larger than 206. And with this method, we can try some other variables. Let me comment those. Let's say if we want to define so basically subsets of data frames can be assigned to variables, and it just as data frames can be assigned to variables, we do example, we want to, for every carbon dioxide level that's larger than 745, we want to call it high carbon dioxide. So we do high. So now we sort of created a new data frame that put together all the rows that has a carbon dioxide level that's higher than 745 in it. And then once we print out the top 5 rows, as we can see, it will show us the top five rows that has a CO2 larger than 745. And we can see on the very left here, the index number is not from 0, 1, 2, 3, it's 0, 6, 7, 8, 9. So basically the program picked up the lines that with the condition that carbon dioxide is larger than this 745, and then show the lines that meets the requirement. And we can also choose to look at certain columns in the data frame. For example, we do, let me make this gray so we don't, when print, we don't get distracted. Let's say we only want to say PM and temperature columns. And we want to see the head. So keep in mind, we need 2 brackets over here because one bracket refers to the name of the variable, and another one refers to the data file. So that's why we got an error. So now we print out the first 10 rows with only PM and temperature variables. Sorry, from 10 rows with only those 2 variables. And so we went through how to see the top 10 and top 20. And what if we want to focus on certain rows, let's say from 20 to 40? And this again is very straightforward. Data file 20 to 40. It's the same as when we went through how to do like a range, how to set a range of lists. It's always first index, last index, and then steps. And here we're not doing steps. And now the program will show us from the 20th to the 39th of the rows. Again, they show till 79 because started from there. And there is also a data frame called group by function. And group by is used to split the data into groups based on certain criteria. And pandas objects can be split on any of their axes. And the abstract definition of grouping is to provide a mapping of labels to group names. For example, let's do a group by VOC. I keep using VOC. It just seems like that the number in there is very straightforward. Group by. You guys don't have to like. Feel free to try other variables such as PM or like carbon dioxide or even time on your end. And let's see what we have. So like here, it kind of sort or categorized based on certain materials in pandas. It's just sometimes it's a classification tool to use. And again, I'm not so because I'm not environmental science. I just use data sets as examples. So feel free if you're specializing in any other data, you have any other data set or data frames that you want to use, and definitely try this method. And there's for different each libraries, for example, pandas, they always have like a official tutorials with all the commands in it. So today I only showed you guys a certain command inside pandas, but apparently there are millions more of commands or functions inside pandas. And there is a link to it. I will not share right now, but it's definitely it's inside our Google Colab document. So if you want to look more into pandas, feel free to go to their website and take a look. And again, I will send an email at the end of this workshop, and then you guys should have access to all the documents and video recordings and etc. And now let's see, we have half an hour to look at Matplotlib. So we imported pandas, we'll leave it as it is, and then import Matplotlib. It's MAT, it's already here. I usually call it PLT. Oh, one setting is that if you import, doesn't matter if it's pandas or Matplotlib, you get an error. It's probably because you haven't configured those libraries into your IDE or your Python shell. So I'll show you guys how to do that in PyCharm. But if you're using a different IDE, then you can also install it in your terminal. So here, for Mac, you use preference. I don't have a Windows device, so I'm not sure how to do that in Windows, but as I'm pretty sure it's similar. So we go to, 1 second, let me see. What is that? It's called not appearance. Let me quickly look up that. All of a sudden, I forgot that feature name. I think they have a library. No, not this one. It should be, let's try interpreter. Yeah, it's called a project interpreter, sorry. So here you can see they have different packages. And you'll see if you have pandas, for example, today we used pandas, right? So we can just use import pandas because it's already installed. And also Matplotlib is over here, it's installed. So if you do not go to project, if you get an error saying that package is unavailable, it's probably because you haven't configured it yet. So you can go to type in a project interpreter, and then there is a plus command over here, and then you can just search whatever the name of the package and install it over here. Or what you can do is you go to a terminal. For Mac is terminal. I don't know what's it called for Windows. You do something called, I'm just not going to have my terminal open right now because it's just too many windows. It's called pip install. And then you can pip install PNDS, pandas, or Matplotlib. Just use this line in your terminal and it will download the packages that you need. All right, let's go back to Matplotlib. It just a quick overview of the problem that I've encountered before. So Matplotlib is a visualization library in Python for 2D plots of arrays. And Matplotlib is a multi-platform data visualization library built on NumPy arrays and designed to work with the border SciPy stack. And it was introduced by someone called John Hunter in 2002. And so matplotlib.pyplot is a collection of command style functions that makes Matplotlib work kind of like MATLAB. So I'll just, under Matplotlib, there are a lot of different types of packages, and I'll show you guys something called it's called pyplot over here. And now we start with basic plots in Matplotlib. Matplotlib combines with like a wide variety of plots, and plots helps you understand trends, patterns, and make correlations. And they're typically instruments for reasoning about quantitative information. And we start with a very, very basic line plot. We have x-axis values, and then x is, I'll start simple, 1, 2, 3, 4, 5. It can be anything, like on your end, you can type in whatever number you want to try it, 2, 4, let's do 8, 16, and 32. That's y-axis values. And then function, here is a function to plot. So PLT refers to matplotlib.pyplot. And again, this is just a variable name and it can be anything, whatever you want to call it. And usually, normally people call pandas PD, and then Matplotlib pyplot as PLT, and NumPy as NP. But again, you can use whatever variable to call it. And we print XY. can you guys see the plot that just popped up? I think it ran in Python shell that it's not in PyCharm anymore. I will change the share settings. So yeah, so here is a plot that's that we got from our function. It's a very straightforward line plot, and then we can do a bar plot or bar chat or bar chart, whatever you call it. X. No, I'll use the same X. The only difference between a bar and a line chart is line chart here is plot, and then for bar is bar, and everything else are the same. And we run it. All right, so now we get a bar chart like that. And then next be histogram. The different, so for histogram, we can only do one variables right now. So we'll, and this is hist. So here is the histogram. And the difference is one is bar, one is plot, and this one is hist. And then we can go to a scatter plot. I use the same X and Y axis just because I don't want to type different lists. But if you want to try different variables and numbers, definitely try it out. And the whole series is kind of straightforward. If we want to do a scatter plot, it just literally called scatter. Oh, whoops. Oh, here's a problem. And here we got a scatter plot. And as we can see, all the plot we saw was kind of like straightforward. And what if we want to format in it? So let's say let's start again with line plot. We want it to be blue. No, we had blue already. Let's do green. You can just type in either green or just do a G. And we don't want to see, we don't want to do dots anymore. We want it to be like different plus. Or we don't want to be lines. Let's just start with green first. And let's run it. So here our line changed from a blue line to a green line, and we can do red, we can do yellow. Red is R, yellow is Y. And if we don't want it to be a line, we can also make it a plus. So that will change our line from a line to like a plus mark. Well, I'll show you in a minute. See, that's what it looks like now. We see like every XY point became a little plus dot, and we can also do circle, stuff like that. You can explore different sort of marks yourself. And we can also do like the line width. For example, we want to make this one red. And we want to show both the line and the dot. And then we want the width to be Let's do 2. I wasn't so sure like which one looks the best. Marker size, let's do 9. Let's see what this look like. Okay, yeah. Okay, this is not too ugly. So we have a line width of 2 and then a marker size of 9. And here, what if we want to draw 3 lines in a picture? Let's import. That's a different library that specialize in dealing with arrays. And so we have, so I'll quickly explain why we imported NumPy. Because Matplotlib were limited to working with list, and it'd be fairly useless for numerical processing. So generally, we would use NumPy arrays. And in fact, all sequence are converted to NumPy arrays internally anyways. So here is example of, I'll give you example of the NumPy arrays together with Matplotlib. So we have every sample time at 2 interval. T is a variable. So we can see that a range here is a range function. And for all range functions, the syntax is always the same. Starting index, ending index, and the steps. So starting index is 0, ending index is 12. So ending number would be 11. And then we show it, we want to show the number every 2 steps. So here refers to 2 milliseconds. And we want to show 3 different lines, red dashes, and let's do a blue square. And we want to do green triangles. Excuse me. Oh, I typed an extra. Thank you for pointing it out. T. So that's our first line, and then we want to draw our second line. We want it to be, we want our first line to be red dash. So we dash. And then let's go to our second line. So I put it together. Basically, the first is X's, and then second is Y, and then the third position is referring to the style of the line. And then we want to do T square. And the second, what do we ask? A blue square. And the third one, oh wait, here is ×2. And then the third one would be T cube square, and then the green lines and green triangles. Okay. So we always need to do a function called plot show to call our plot. Okay, so okay, great. So here's what our plot looks like. We have 3 lines all together. with blue, red, gray as we commanded. And now one important thing is missing is that we're missing the name of our graph, X-ray and Y-ray. So let's use another example. Let's do money and year. We have 0, 100. I kind of wish my income grows that fast. We have this is too outdated. It's 2020 now. Okay, that's better. Honestly, it doesn't matter. PLT dot. Okay, let's assume that money is in thousand. It's not like we get $100 per year. Okay. Year, and we want to plot year and money. And the way to name our graph is dot title function. And let's call it my account. No, it's called my income. Okay. And plt dot x. Ticks. That basically that sets the step number of x-axis. Otherwise, it will return. The reason that I define a 1 here, because the default will be 0.5. So you'll see a 2020.5 in between 2020 and 2021 if I don't do that one-step commit. And here is we want to show like every 50. So the that's basically set the range of a y-axis, the bar. Usually it'll give you a default, like you don't have to set it. But here I set it to 50 to show basically from 0, 50, then 100, 150. And if you don't set it, it's fine. Like usually Python would like automatically generate the one that the programs think is the best fit. And then the name of the x and y axis, it's x label, year, and y axis. That's called money. And let's look at our plot. Huh. Okay. Yeah, so now we have the money, the name of the y-axis and name of the x-axis called money and year, and then the whole name of the graph is my income. And this line is very straight. um, and I'll quickly show what would happen if I do not set the range over here. This is kind of annoying. So yeah, so what happened is I don't set the range over here. It will sort of default to 0.5. And we don't want that because it's a year. And moreover, we can also do plotting with categorical variables. So basically, Matplotlib allows us to create a plot using categorical variables, which means we can pass categorical variables directly to many plotting functions. So one example is that we can do like in let's say if we do experiment and we have different set of test groups. And one thing that Matplotlib can do is we can also draw 3 pictures in one row to compare, let's say, 3 different groups. So I will make those gray. Let's say we have 3 groups called Group A, Group B, Group C. Values. And that's like a general large plot, right? And then we want to have 3 different subplot that reflect group A, B, and C. And we can do a command called plot.subplot. So this refers to the number of rows and the number of pictures in one row, graphs in one row, and then the index number of the graph. And first we want to do our bar chart. One, 3, 2. And then the second one, we want to do a scatter plot. And the third plot, let's do a line chart. And we want to call this entire graph super title is called categorical plotting and plot. Oh, this is so ugly. So sorry, yeah. So as we can see, the default setting is Python kind of squeezed all the charts like together, and we want it to look better. And so what we can do is we can define the size of my chart. command is figure. And then fig size. We want it to look like square. So this one is 12 is the length of the super plot, and then the 4 is the width of the plot. Since we have a 3 plot, right? So 3 times 4 is 12. So we assume that our plot will look like squares. Let's see if it actually meet our expectations. Okay, yeah. Great, fantastic. So we got our plot that's sort of like squares and looks better. And other than having 3 pictures in a row, we can also have 2 comparison pictures in 2 rows by 1 column, right? Or you can do 2 rows and 2 columns. So I'll give another example. NP is on the NumPy. Now I'll start adding comments. So create the first 2 So here, the previous plot, we had 1 here, which refers to the number of rows. So we have 2 rows. And then this one refers to the number of columns. And previously we had 3 columns. And this one, we decided to only have 1 column. And then the index number is 1. Rows, columns, and whatever you call it, index number, panel number, graph number, PL. Now we do plot. X. Let's do the sign of X. And let's do the second one. Now this one should be 2, 1, 2. And then plot. This is also a line plot. And then let's do cosine. So X is basically any numerical number between 0 and 10, right? And let's show our plot. Okay, so now we get 2 rows of grouping comparison graphs of sine and cosine X. Okay. Okay, and we have, let's see, 4 more minutes. Let's quickly do like a comparison of GDP. I will share this another URL. Let's 1 second. Let me go to my GitHub again. I accidentally closed it. GDP. So I sent another link in the chart. This one is very, very tiny, small CSV file. It's basically the GDP of Australia and New Zealand from 1952 all the way to, let's see, 2007. Wait, my bad. I didn't hit raw. The second link. And now let's import it. URL. So I added an index column is because if you take a look at that spreadsheet, on the first row is the year, and then the first column is a country. So which means we have one index row and one index column. So we want to tell the program that the very first column is not our data. It is our data. It just it refers to the name of the country, not the variables. And so if you click that link, you see the problem was that that data set is for years, it's not a straightforward year. It's GDP per cap dash, not dash, underline 195, GDP per cap, underline blah, 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 157, and then year. So we just want to we just want to take out the year data specifically, excluding the GDP per cap part. So we do a strip. Columns. Strip. And then in the beginning, our name, the name of the year is a string, and now we convert it to integers. Inside NumPy, we convert, when we convert types, there's a function called astype. And then now we want to show Australia. Okay, let's see what error we have. Index country invalid. Let me go back to my data file and see index column. country. Oh, there's no cap. Okay, now it's working now. So now we see, this one shows the GDP of Australia. Okay, and then so it's 4:32 now. When you guys have time, do go back home and draw the line of New Zealand as well, and then also try to draw a comparison, a picture that combines Australia and New Zealand together, and show them together in one graph, and do like a line chart. So that's about it for today. And for next week, we will again quickly go over a bit more about Matplotlib, and I believe next week we'll do more about functions and exercises. So yeah, that's about it for today. And thank you for coming. And if you had any questions, I saw like a lot of people ask questions in the chat. I didn't really have time to like look at everything during the workshop, but if you stay a bit longer, like I'll be back at 4:40, and feel free to ask me all the questions you have. And if you don't have any questions, feel free to leave the meeting. And again, I will send out the recordings, all the materials, notes, and everything through the email. Will you teach us how to use Python to edit the data in, because it's a huge, in terms of edit, like are you talking about like delete rows or delete columns, stuff like that? If you want, we don't, well, I believe there's a command like DLT in pandas that you can use. We don't have a separate workshops just for that, but if you are interested, there is a link inside the Colab notebook that has all the command and parameters of pandas, and they have a session about how to edit files. But honestly, with my experience, unless your file is super large, it's I wouldn't ever recommend you to delete anything from your original file. But like I showed you earlier in today's workshop, is that we, instead of deleting the whole files, if you just want to see two variables, right? Today I showed you how to just see two variables, three variables. You just and see certain lines of different variables, and then you can save them as a new different data frame and then add it through there. But do not ever delete your original file or make any edits on your original file. That's highly unrecommended. Because, for example, you may delete some information that might be useful for other people to use in the future. Yeah, no problem. And also, my experience is always faster to do it in Excel. Trust me, it's always faster to just delete and do. So I always do like the first step, like data cleaning, uh, and um, and I always do my data cleaning just in CSV. It's always faster. All right, I'll be back at 4:40, and at 4:40, you guys can turn on your microphone and just ask me questions there. Okay, I'll just quickly go grab a coffee, and I'll be right back.